As per the conventional model of cosmology, around 13.8 billion years ago, the universe underwent the Big Bang, initiating the continuous process of expansion. This expansion implies that large celestial bodies are moving away from each other. Consequently, the galaxies observable beyond our Milky Way are in motion away from us. To gauge a galaxy's distance, a metric known as cosmological redshift is employed. In essence, a higher redshift signifies a greater distance of a galaxy from us. However, there is a complication. Light emanating from distant galaxies undergoes stretching into infrared wavelengths beyond the detection capability of the human eye. The Hubble Space Telescope's observational range extends from ultraviolet to near-infrared light, limiting its ability to detect extremely distant galaxies, such as GNZ11, which exists 13.4 billion years in the past, just 400 million years post the Big Bang. GNZ11 boasts a redshift value of 10.957, making astronomers believe that galaxies beyond redshift 11 were scarce. The James Webb Space Telescope, equipped to detect infrared light, changes the game. Launched and directed towards the cosmos, it unveils a different universe from the depths of time. The telescope reveals dozens of galaxies that could rank among the earliest in the universe. Early observations identify galaxies at high redshifts, indicating they formed earlier than expected. NASA's scans detect galaxies that might be the universe's first, emerging 200 to 300 million years after the Big Bang. The oldest galaxy, Glass Z13, with a redshift of 13.2, formed just 300 million years after the Big Bang. This abundance challenges previous notions of galaxy formation, suggesting a need to revise our understanding, as stated by the lead astronomer at the University of Missouri. The findings hint that many galaxies could have formed much earlier than previously thought. The scientific community was taken aback by the recent discovery as another primordial galaxy emerged, this time existing a mere 390 million years after the Big Bang back in August 2022. Fast forward to the present, with the assistance of the Webb Telescope, more of these high redshift, fully formed galaxies have been identified. What makes them even more intriguing is their distinct appearance. Two of the most distant galaxies ever observed have been pinpointed by the eagle-eyed James Webb Telescope.
The first, designated Uncover Z13, boasts a redshift of 13.079, allowing us to observe it as it existed just 330 million years after the Big Bang. The second, recently discovered Uncover Z12, possesses a redshift of 12.393, positioning it at a mere 350 million years post the Big Bang. Notably, what sets these two galaxies apart from others at similarly high redshifts is their structural complexity, in contrast to the typical point-like appearance indicating smaller size. Previously, galaxies discovered at these vast distances typically appeared as dots in images, but the latest observations have unveiled distinctive characteristics. One of these galaxies, Uncover Z12, displays an elongated shape resembling a peanut, while the other exhibits a fluffy ball-like appearance. Moreover, these galaxies are notably larger, with Uncover Z12 featuring an edge on disk approximately 2,000 light-years across, 6 times more extensive than other galaxies from that era. Despite their anticipated formation from similar materials, these early galaxies, closely linked to Uncover Z13, are already displaying noteworthy differences. Notably, the James Webb Space Telescope's capabilities extend to observing even higher redshift galaxies. Presently, the SERIRS team is evaluating around 10 more galaxies, suggesting the emergence of massive galaxies at a faster rate than previously assumed, according to Fabio Picucci from the Harvard-Smithsonian Center for Astrophysics. The ages of some of these early galaxies are estimated to be just tens of millions of years, posing potential implications for the large structures of dark matter known as halos, which, according to our cosmology, played a role in shaping early galaxies. Despite some challenging and potentially model-busting candidate galaxies from the early universe, a notable discovery came from a team of scientists at Swinburne University of Technology in Australia. They identified galaxies with billions of solar masses, comparable in weight to the Milky Way, forming just an estimated 750 million years after the Big Bang. These galaxies, 10 to 100 times larger than those seen previously in this era, are densely packed into structures 30 times smaller than the Milky Way. What's particularly intriguing is that these galaxies appeared to host many more stars than previously thought possible, challenging the foundational understanding of how massive structures develop over time according to the cosmological standard model. Furthermore, recent observations by Webb revealed the Milky Way galaxy as a large and complex galaxy, similar to Milky Way-like galaxies at the edge of the universe. These galaxies, according to our physics, should not exist. Many early galaxies, akin to those detected by Webb, were rich with glowing gas, so bright that the gas itself could outshine stars emerging from within. These new findings unveiled the commonality of such shimmering, infant gassy galaxies in the 13.8 billion-year-old universe when it was only around 2 billion years old. Observations indicate that almost 90% of these galaxies exhibited extreme emission features, showcasing the prevalence of glowing gas. While studying these early galaxies, astronomers unexpectedly discovered the most distant example of a galaxy in the universe, resembling our home galaxy, the Milky Way. Our Milky Way is a spiral galaxy with a similar bar, and scientists suspect that the Milky Way's bar rotates cylindrically, directing gas into the galaxy's center and triggering bursts of star formation. Astronomers had previously believed that the presence of a spiral galaxy in the universe was a conclusion of a galaxy's formative years, expecting it to be observed only in older galaxies that might have reached full maturity, possibly existing halfway through the evolution of the universe. Contrary to earlier assumptions from Hubble Space Telescope observations, recent data from the Webb Telescope challenges these notions. The new findings suggest that barred spirals like CIRS 2112 may not have been exclusive to recent times in the universe. The discovery of spiral galaxies resembling our own, such as CIRS 2112, implies that these structures already existed almost 12 billion years ago when the universe was just 15% of its current age. CIRS 2112 is observed at a redshift of 3, indicating that the light from the galaxy took nearly 12 billion years to reach the James Webb Space Telescope. This discovery challenges previous assumptions, as galactic bars were thought to have formed about 4 billion years into the universe's existence. The standard model of cosmology had predicted that the early universe's physical conditions would have hindered the formation of such barred galaxies in general. The surprising presence of these galaxies, even in the face of theoretical predictions from cosmological simulations, struggling to reproduce such systems at those epochs, prompts a need to identify the missing key physical ingredient in our models. The narrative also touches upon the influence of dark matter on galaxy evolution and star formation, positing that dark matter played a significant role as early as 380,000 years after the Big Bang. The call for comments and subscriptions to the channel is an engaging invitation for viewers to share their thoughts on these groundbreaking discoveries.